Alright, so I think this is recording. Let's take a look at this problem. We've got a graph and they're asking us to come up with the equation. The graph appears to be the graph of an exponential function. We know that exponential functions have this basic form of b raised to the x power. And we can determine whether b is, there's some restrictions on b. It can't be negative, and we don't allow it to be 1. Alright? When b is a proper fraction, when it's between 0 and 1, then the shape of the graph, you'll see it's a decreasing function. It looks like this. As you move to the right, the graph is going down. So that appears to be what we have in this problem. So the first thing that I notice is that I think when I do determine what this b is, it's going to be a number, it's going to be a fraction that's less than 1. Because if the graph had been increasing as I move to the right, then I would expect that b to be a base that's bigger than 1. But I believe that just based on inspection here, that this base is going to be less than 1. Now, sometimes this basic function, when you have transformations on it, one of our transformations is a graph that is shifted up or shifted down. Your basic exponential function will have a horizontal asymptote that's the x-axis, that's a line y equals 0. And it looks like our graph here has a horizontal asymptote of the line y equals 0. So that's leading me to believe that from our basic, this b to the x is not being shifted up or down. So in other words, we're adding 0 to this. We normally don't write plus 0, but that kind of helps me at least think about the vertical shifts up and down, that there is none. Now what about shifts left and right? Normally, this b to the x, when x is 0, when you have b raised to the 0 power, it's equal to 1. So normally, a basic exponential function will be passing through the point 0, 1. But this graph is not passing through the point 0, 1. Okay, so I suspected there was no shift up or down. What about a shift to the right? What if this point got shifted to the right 1 unit? And if we move to right and left, that's going to be adding or subtracting a value to x. And it's bizarre in its behavior. Even though we're moving to the right and we think of right being positive, we're actually going to subtract. So I believe that what I have here is some base that is less than 1, and the exponent is x minus 1. Now, I have other points that I know that are on this graph that will satisfy this equation. So I'm going to try and read off another point. Because this graph is so steep, sometimes it is difficult to find points to read off of it, but it does look to me like the point 0, 3 is on the graph. Oop, not 0, 1. 0, 3. So that means in our equation here that the left-hand side y, well, that's going to be the number 3, and on the right-hand side, this x, that's going to be the number 0. And 0 minus 1 is negative 1. Alright, now I need to solve this equation for b. And when we have negative exponents, we can rewrite it as a positive exponent if the base changes location of where it's at within a fraction. Currently this b is up in the numerator and it has an exponent of negative 1. If I move this b down to the denominator, I'll have to change the sign on the exponent to a positive 1. And now I can either cross multiply, or another technique when you do have a proportion, you can take the reciprocal of both sides. Taking the reciprocal of a fraction means flipping it. Mathematicians use this word reciprocal. Most of us, if we're sitting around the lunch table talking about math like I do, I just say flip it. Okay, and if I flip this side, b over 1. And b divided by 1 is b. So now I have my answer. Remember that I had already knew the exponent, or at least thought the exponent would be x minus 1. I was using this extra point 0.03 to help me determine what b is. I've determined that b, this base, is the fraction 1/3, and 1/3 is definitely less than 1. So everything looks pretty good, and I'm going to stick with this answer. I believe that this equation has been graphed right here for us. Hey, I hope that helps, and I'll talk to you later.